All right, everyone, we're going to start our video now. Okay, one sec. All right, so what is it that we're doing today? Proving lines parallel. Proving? Yeah, I'm not doing it. Okay, so you promised. This isn't a secret proofs lesson. It's like more of last lesson. Okay. All right, I guess I'm back. So let's talk about the angle relationships. Angle relationships, postulates and theorems, really? Okay, you're on thin ice. So, to start with, let's talk about this one. The corresponding angle postulate. So, last class we learned when two lines are parallel, corresponding angles will be congruent. And that's what this corresponding angle postulate says. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. This is a postulate because if you look, these two angles look the same. And if you think about it, they're going in the same direction. They're being hit by a line in the same direction. It makes sense that these ones would be the same. That's why it's a postulate. You don't have to prove this one. Now, we also have what is called the converse of the corresponding angle postulate. Now, you might remember, converse is where we take the original conditional statement and we flip the hypothesis and the conclusion. So now instead of saying if two parallel lines are cut by a transversal, then the pairs are congruent, it's now if two lines cut by a transversal have congruent corresponding angles, then the lines are parallel. So the converse is where we use the angles to prove the lines are parallel, whereas the original one is because the lines are parallel, the angles have to be congruent. So let's look at another one. The alternate interior angle theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. And as you might guess, the converse of the alternate interior angle theorem ends up just being where we flip the hypothesis and the conclusion. It's now, if the alternate interior angles are congruent, then the lines are parallel. So if we are out to prove that the angles are congruent, we would be using the angle theorem. If we are out to prove the lines are parallel, we use the converse. Okay. So next it looks like we're talking about alternate exterior angle theorem. If two parallel lines are cut by a transversal, then the two pairs of alternate exterior angles are going to be congruent. So in this case, 2 is congruent to angle 7. Now, the converse of the alternate exterior angle theorem is if 2 is congruent to 7, then the lines are parallel. It's pretty much exactly the same as the rule from the last one. It's pretty much the same idea. So now let's look at this. It's same side interior angle theorem. So if two parallel lines are cut by a transversal, then two pairs of same side interior angles are supplementary. You can tell, by the way, that these are supposed to be supplementary because if you look at them, and I know this isn't good math, but you can kind of tell 3 is acute and 5 is obtuse. Now, is that always going to be the case? No, and that's the point I would make if you tried to say that you didn't have to do the math about it. But it can give you the hints necessary to get to understand it better. So when you look at it, whereas alternate exterior angles or interior angles looked like they were kind of both acute or both obtuse, same side interior, or as we're about to see, exterior angles, one looks acute, the other looks obtuse. So now let's go to the converse. The converse, as you might expect, is if 3 and 5 are supplementary, then the lines are parallel. All right, and finally we have the same side exterior angle theorem. If two parallel lines are cut by a transversal, then the two pairs of same side exterior angles are supplementary. The converse of the same side exterior angle theorem is if two lines are cut by a transversal so that the pairs of same side exterior angles are supplementary, then the two lines are parallel. So basically, once again, if the lines are parallel, then same side exterior angles are supplementary. The converse is if the same side exterior angles are supplementary, then the lines are parallel. So now let's try doing some math. And I mean, if I see a single given or prove, I will walk away. So here we go. Oh, okay. This is pretty much like what we did last time. So the measure of angle 4 is 127 degrees. In this case, what does the measure of 5 have to equal in order for these lines to be proven parallel? So if we look at them, angle 4 and angle 5 are alternate interior angles. And if you look at them, you can see they both look like they're obtuse, which means that they would have to be congruent. So in this case, 127.325 degrees. Okay, so let's try another one. All right, in this case, angle 2 is 68 degrees, so we're looking for angle 8. Well, let's see. Angle 2 and angle 8 are same side exterior, which means they should be supplementary. But also, if we just look, 2 looks like it's acute, and it is, which means 8 would have to be obtuse. Looking at it, you can tell that they aren't meant to be the same angle. So we would do 180 minus 68, and that gives us 112 degrees. Okay, so now we have 4 and 5. 4 and 5 are alternate interior angles, and I am not guaranteeing that this is going to be right because, we could end up telling you that angle 4 and 5 are both 20 degrees, but looking at it, it appears that angle 4 and angle 5 are both obtuse, which means they should be congruent, not supplementary. So in this case, that means if they are congruent, 13x plus 6 is going to equal 14x minus 4. So I subtract 13x, and then I get 6 is equal to x minus 4, which means we add 4. X equals 10. So now that we know that x equals 10, 13 times 10 is 136, and 14 times 10 is 140 minus 4 is 136 degrees. So as we can see, they are in fact congruent, or at least when x is 10, the two lines end up being parallel because they are congruent. This is seriously exactly like last time. So I'm feeling a lot better. Okay, so here we have this one, 3 and 5. So let's see, 3, 5. Well, they don't look like they're the same angle, and sure enough, they are same side interior, which means that they are supplementary. So we add them together if we want these lines to be parallel. So in this case, 20x minus 5 plus 68x plus 9 equals 180 degrees. All right, so let's see. 88x plus 4 equals 180 degrees. Minus 4 minus 4. 88x equals 176. Divide by 88. That means x is going to have to equal 2. 40 minus 5 is 35. And then we get 145 degrees when we do that. So there we go. That was not nearly as bad as I thought it would be. I'm actually feeling pretty okay. All right. The next slide is just what I always ask you all to do at the end. Just please like and subscribe. This is even the exact same one as last time. I'm feeling much better about this. Okay. So yes, like and subscribe. What is going on? Oh no. No, no, no. No, no, no. No, no. No, we aren't doing this time. Okay. A proof. So in this case, the first line we already know. We know the first line. The first line is the given. So angle 1 is congruent to angle 2, angle 3 is congruent to angle 1. And the reason we know that is because it's given. So now we have to go, what do we notice from the given? So in this case, 1 is congruent to 2 and 3 is congruent to 1. That means 2 and 3 are both congruent to 1. And if they're both congruent to angle 1, then they should be congruent to each other. And that is because of the transitive property of congruence in this case. And if angle 2 and angle 3 are congruent, well, let's see. There is a transversal right here. And we have two lines right here. So what is the relationship between those? Well, they're on the inside of the two lines and on opposite sides of the transversal, which means I can say XY is parallel to WV, and it's because they're alternate interior angles, the converse of. So there we go. Let's move on. And sure enough, like and subscribe, everybody, for more great content like this with proofs. That's what my channel is now. A proof channel. I have a film degree, and I'm making videos about mathematical proofs. See you all next time. Bye.